Rightio, today we're talking about respiratory acute responses. So first of all, we just need to define this a little bit. So the respiratory system extracts oxygen from the air when we inspire or breathe in, and removes carbon dioxide from the body by expiring or breathing out. It includes most importantly the lungs and breathing muscles such as the diaphragm, which help inflate the lungs, and most importantly the alveoli in the lungs allow for oxygen to be diffused into the blood, so that's oxygen into our bloodstream, and for carbon dioxide to be extracted from the blood to exhale out of the body. Righto, so we'll move on to a little animation to help us explain a bit more about what acute responses to exercise there is from our respiratory system. So you can be stopping and taking notes as we're going through this. Okay, there's 4 acute respiratory responses to exercise. So these can be your headings. Increased tidal volume, increased respiratory frequency, increased ventilation, and increased diffusion. Let's look a bit more deeply into all of these. Number 1, increased tidal volume. So, with this, similar to stroke volume in cardiovascular, it's an amount we're talking about. And this amount is how much we breathe in one breath. We measure this in litres, and litres of air, not just oxygen. And at rest, we only do about 0.5 of a litre, and at maximum, that goes up by 6 or 7 times to about 3 to 5 litres. Number 2, we have increased respiratory frequency. So all this is how many breaths you take in and out per minute. So at rest, we generally take in about 12 breaths, and at maximum, we can 3 or 4 times that, we can go up to 35 or 50 breaths per minute. And our last one, ventilation. Okay, so now we're putting the last 2 together, okay, to make up our ventilation. It is sometimes called minute ventilation because it is your amount of air breathed in per minute. It's also measured in litres per minute, okay, and it's calculated like this. Ventilation, which is often regarded done as V, equals tidal volume, which is TV, times by respiratory frequency, which is sometimes written as RF. Okay, at rest it's about 5 to 6 litres per minute, and at maximum it can go 20 to 30 times higher than that at 130 to 180 litres per minute. So, let's have a little example of how this might work. Okay, so I'm off running around. Let's see what happens to my ventilation. Okay, so let's try an example here. If my tidal volume is 3 litres, so that's 3 litres per breath, and I times that by 20 breaths per minute, that means I will get 60 litres per minute as our ventilation value. So our tidal volume was 3 litres, times that by your respiratory frequency, which is 20 breaths, equals 60 litres per minute. Last one, increased diffusion. If you've done some science subjects, you may know a little bit about this. Okay, and what happens is diffusion is oxygen moving from an area of low concentration to an area of high concentration. I'll draw up a nice pretty diagram in class that we can copy down, so leave room for that. Now this happens at 2 places. At the lungs, okay, so this is where we talked about before, oxygen is exchanged between the alveoli, Okay, that's in the lungs, and the capillaries, which is the blood vessels. It also takes place at the muscles. So our muscles need oxygen, so oxygen is exchanged between the muscle tissue and the capillaries, the blood vessels, which are pumping the oxygen and blood around the body. We'll go through this much more in class. Let's get the notes down and we'll try and understand it better a little bit later. Okay, so those were the 4 main acute respiratory responses. Okay, we will, as long as you do your notes, we will start the questions in class. I'll see you next time. This has been another Saunders production. Thank you. Bye.